with y. In this case, y is less than 4. Y is less than 4. Step 1 is to write the y by itself, which is already done. And so we write its boundary line. The boundary line is y equals 4. We graph the boundary line y equals 4. Remember what the line y equals 4 looks like? If we make our table of values, remember that the y value is stuck at 4. So for all the points in our table, the y will be 4. The x will be anything we please, for instance, -2 and 1 and 3. And so let's graph each of these points. We have -2, 4, which means from the origin we count to the left 2 and up 4. 1, 2, 3, 4. 1, 4. From the origin we count to the right 1 and up 4. 2, 3, 4. 3, 4. From the origin we count to the right 3. 1, 2, 3 and up 4. And we notice that all of these are on the same horizontal line. So y equals 4 is the horizontal line 4 units up above the x-axis. Back to the inequality. Y is less than 4. Notice the equals is not included. And so we're going to graph y is less than 4 with a dotted boundary line. So the dotted boundary line, the dotted horizontal line. And we want the portion where y is less, which means we will go below the boundary line. Well, this time the above and the below are certainly easy to distinguish. We want the part that is below the boundary line. So everything that is below the boundary line is included. The check is so simple, it's really trivial, but I will illustrate it for you just to keep consistent. We'll check something above and something below. For a point above the boundary line, we might choose, say, this point, which has coordinates 3, 1, 2, 3, 4, 5, 6, 3, 6. When we check this point, we fill in for the y value, 6. The x value is not mentioned, and so the x value is ignored in the check. We simply omit it, since it was omitted from the original inequality. And so we have 6 is less than 4, which is false. This point above is in the unshaded region, which tests false, and that's correct. For a point below the boundary, we'll use our favorite point, 0, 0. And once again, for the y value, we fill in its number, which is 0. For the x value, we don't fill it in since the x is not included. We get 0 is less than 4, which is true. And 0, 0 is in the shaded portion. It's supposed to test true, which means the check verifies we did shade the correct side. One last example. This one does not involve y at all. We're to graph x is greater than or equal to -2. X is greater than or equal to -2. Our first task is to solve for y. However, y is not present in this inequality. It is impossible to solve for y. Does that mean we cannot graph this inequality? No. We still can graph it. We graph it by graphing its boundary line, which is x equals -2. Its boundary line is x equals -2. For the graph of x equals -2, our table of values is very easy to obtain. The x is stuck at -2. the y is not mentioned, and so the y is free to be anything we please, like, for instance, -1 and 0 and 4, anything we please. The graph, -2, -1, to the left 2 and down 1, -2, 0, to the left 2 and on the axis, -2, 4, to the left 2 and up 4, 1, 2, 3, 4. A vertical boundary line, we're graphing x is greater than or equal to -2. Since the equals is present, we do draw a solid boundary line. That is, the boundary line is included, and so the boundary line is drawn solid. And then we must decide where the shading goes. What about above and below? Above, below, well, they're not two different sides of the boundary line. The boundary line is vertical, and so that means the two sides of the boundary line must be, for this particular one, to the left and to the right. Left and right are our only choices. Which way does the x get greater? X gets greater when we go to the right, and so shading should be to the right. However, I'm not going to do it yet. Let's use our check to verify which side should be shaded. Let's pick a number to the left and a number to the right, a point rather to the left and a point to the right of the boundary line. We're checking x is greater than or equal to -2. A point to the left, well, let's use this one. The coordinates are 1, 2, 3, 4, -4, 1. So our point -4, 1 is to the left. For the check, we fill in the x value, which is -4. We get -4 is greater than or equal to -2. But -4 is not greater than or equal to -2. That means we have a false, and therefore this side should not be shaded. A point to the right, we'll use our favorite, 0, 0. We're testing x is greater than or equal to -2. We fill in the x value, which is 0. And we get 0 is greater than or equal to -2. 0 is greater than every negative number, so this tests true. That means that we will shade the side that does have 0, 0, which is to the right of the boundary line. That means that our first inclination to say that since x gets greater as we go to the right, therefore we shade the right, was correct. So we shade the right-hand side of this graph, and I need to draw it all the way out to the edge, actually. We shade every point to the right of this boundary line.